So how exactly does geo-exchange work? It's important to understand that in any system, we heat rooms by adding warm air, but we don't cool rooms by adding cool air. We cool rooms by taking away hot air. It's a disarmingly simple and elegant technology. In winter, it draws heat from the ground and transfers it to the building. In summer, it extracts heat from the building and transfers it to the ground. Water circulates through underground pipes that carry heat between the ground and something called a heat pump in the building. The key to this technology is that the Earth's temperature doesn't fluctuate as much as that of the air. The temperature of the Earth is fairly constant, about 66 degrees year-round, so it doesn't take very much energy to get up or down to room temperature from there, whereas the outside air temperature can vary much more widely.
In a geo-exchange system, if the ground is at 60 degrees and you want the building to be cooled to 70 degrees, then the mechanical system has to overcome a 10-degree temperature difference. If it's 105 degrees outside and you want the house to be cooled to 70 degrees, the mechanical system has to overcome a 35-degree temperature difference. And that's the key thing about why these systems are so much more efficient.
Geo-exchange uses earth and water, two ingredients that are non-polluting and in plenty of supply at virtually no cost. And geo-exchange uses less electricity because it doesn't have to heat or cool the air as much as a traditional heater or air conditioner to get to the optimum temperature. Unlike a traditional air transfer system with gas heating that we see in most buildings, the geo-exchange system requires no burning of fossil fuels for heating. No burning means no pollution. It's day one of Brian and Jerry's experiment. The first step is to drill holes and install pipes. It will take about 8 weeks to complete the installation, and within a month after that, Brian and Jerry should have a good sense of how well the system is performing. Their goal is an energy savings of 15%. The Environmental Protection Agency has called GeoExchange the most environmentally clean space conditioning system available. It completely eliminates the consumption of fuel emissions in the heating and cooling of a building. No burning, no exhaust, no pollution, no noise, no enormous, ugly compressor units on rooftops. Installing a GeoExchange system in a typical home does as much to reduce greenhouse gases as planting 1 acre of trees annually. The next step is to hook up the pipes. Then the equipment room is fitted out. The pump room takes up about a third less space than a traditional system. Everything's more compact. It's the single source for hot and cold water, and it can be used with existing ductwork. The next step is the sheet metal ducting work. The final step is to install the controls, thermostat and boxes, for monitoring the system. All of this is carefully checked. The systems are now in place. The dream has become a reality. The real experiment is about to begin.
All right, we're up and running.
Jerry, thank you very much.
Okay, Brian.
Successful project.
All right, we'll see how it works.
When it came on and when it cooled and when it heated, I was ecstatic because I knew that the risks were really behind us because we knew that it worked. And it demonstrated that from the first hour of the first day. And there were no problems with the system. It worked like putting on a watch. It was phenomenal.
Soon the data start coming in, and the analysts check the results.
If I understand, this is going to be the first live, side-by-side presentation of this technology, of GeoExchange heat pumps.
Well, this is a study that nobody else has really done yet. This was one of the challenges that we had as to what do we monitor and how do we monitor it and to make the data absolute real. The systems are simple. The analysis part is not simple.
While monitoring and analysis will continue for several years, the initial results have exceeded all expectations.
Originally, Jerry and I were expecting 10 to 15% in savings, and that was what we were hoping for. However, when the initial test results came back, it appears as if we have better than 30%.
At a time when oil prices and climate change have soared among public concerns, this technology couldn't be more timely.
Every kilowatt hour that we don't burn is 1.4 pounds of CO2 that doesn't go in the air. This technology is one arrow in that quiver of solutions that it all need to employ. This community is a community that I love, and I want to make sure that it's here for the next generation.